In this video, we're going to be looking at testing the difference between two proportions, right? Remember, a proportion is a value between 0 and 1. Right, so in this scenario, Chifaru, she's going to have quite a few friends that play musical instruments, and she wants to know whether or not her math major friends are more likely than her English major friends to play a musical instrument. Being a data person, she's going to ask 43 of her English major friends. She finds out that 15 of those 43 play a musical instrument, and 16 out of her 28 math major friends play a musical instrument. So she wants to know how can she use these samples and this data to test her hypothesis that math majors are more likely to play a musical instrument. So we're going to be doing a hypothesis test about that claim. All right, so here is our hypothesis test. We have a null alternative hypothesis. We have a significance level alpha. We use our data to calculate a p-value, and if the p-value is smaller than alpha, we'll reject. If the p-value is larger than alpha, we will fail to reject our null hypothesis, and then we want to say something about how this, what this says about what we want to know. All right, and so in comparing these two proportions, right, our null hypothesis is simply that these two are going to be equal to each other. Or another way of saying it is that in H naught, P1 is equal to P2. The two proportions are the same. And as always, our alternative hypotheses come in three types. Right, our P1 could be less than P2. That's going to be a left-tailed test. The arrow's pointing to the left. P1 is greater than P2. That's going to be our right-tailed test. The arrow's pointing to the right. Or P1 is simply not equal to P2, and that is going to be our classic two-tailed test. All right, so let's look at Chifaru's example. In Chifaru's example, let's let our math majors be our ones. So, since the math majors are our ones, we have 16 yeses. That's what we've using x's for our proportions for a while now. We have 28 math majors, so that's our n. And if the math majors are the ones, well, let's call the English majors the twos. So in there we have 15 yeses out of 43 friends. So since 1 is our math majors, our P1 is going to be our proportion of math majors that play musical instruments. And P2 are going to be the proportion of English majors that are going to play musical instruments. Remember that our null hypothesis, right, our default position is going to be that these things are the same. In other words, P1 is going to be equal to P2. The alternative hypothesis was that math majors are more likely to play this musical instrument. So P1 is going to be greater than P2. Or written in terms of math, P1 is greater than P2 is our alternative hypothesis. The only other thing we need is our level of significance. Let's use 0.05. Right? We don't have any reason to do anything else, so let's go with that. Since we live in the future, let's let our technology do our calculations for us. So we're going to use our TI-84 calculator or equivalent. We're going to go into stat, find the tests, and the thing we want is the two proportion z-test. All right, you'd scroll down, hit our two proportion z-test. Since we have our stats already, we're going to input these as stats. The first set of data is for our ones. Remember, that was our math majors. We had 16 math majors that played a musical instrument, 28 math majors that were asked in total. Twos were our English majors. We had 15 of them who played a musical instrument out of 43 English major friends. And as always, I've found a typo. Okay. P1 is greater than P2 is the thing that we are calculating, right? Our claim was that the math majors are more likely than the English majors, right? So the ones are going to be greater than our twos is going to be our alternative claim. And then we're going to calculate. So the output of our two-prop z-test, right? We're testing it as P1 is greater than P2. Right? Z, the first thing that pops up, is our test statistic on the standard normal distribution. Remember that we are assuming the standard normal distribution with the center in the middle here. And this tells us about where on our standard normal distribution we are. About 1.8 is going to be to the right of it. Right? Z of 0 is in the center. Z of 1.8 is going to be off to the right here. Our P is going to be this area. And the p-value is the next thing that pops up. Our p-value of 0.032289 is our p-value. It's the probability assuming the null hypothesis is true, assuming that these things are equal. This is the probability of getting the value as extreme as we have. Our other values that it outputs, P1, all right, is the proportion for sample 1. So about 57.14% of math majors that she asked played musical instruments. P2 hat, right, this is the proportion for sample 2. So about 34.88% of English majors performed a musical instrument. The P hat is what's called a pooled proportion. If I take my data for the P1 and the P2, the overall average that they play as a musical instrument is 43.66%. Specific for this hypothesis test, that P1 is equal to P2, our alternative hypothesis that P1 is greater than P2, at an alpha of 0.05, right, we compare our p-value here. 0.0322 is less than 0.05, so we will reject our null hypothesis and we will accept our alternative hypothesis, that P1 is greater than P2, or that math majors are indeed more likely to play a musical instrument. And that is going to be our conclusion. There is sufficient evidence to show that math majors are more likely than English majors to play a musical instrument.